In this video, we're going to take a look at the volume of our last shape, which is a sphere, and this is going to correspond to section 10.3 of the textbook. So here we have a diagram of a sphere. The spheres are 3D shapes that we commonly see in our everyday lives, such as a basketball or the planets, the moon. So in the center here, we have this dot, which represents the center. So here is the center. And this line that we see from the center all the way to the edge of our sphere is called a radius. So those are words we've already seen before. Now, the radius can be not just in this line that we see here, but this could be from the center to this edge. So it's always from the center to the edge of our spheres. Okay? Now, all around our sphere is technically like a set of points. Like there are different points on the edge of our sphere. So the definition of a sphere is that all of these points around the sphere are an equal distance away from the center. So from here to here is an equal distance, from here to here is an equal distance, here to here, etc. And like the rest of the 3D shapes that we've been learning about, we have a formula for our volume. So our volume in this case is going to be volume, or V, is equal to 4/3 pi and r cubed. So let's just jump into our first example. We're going to find the volume of this sphere and we're going to round our answer to the nearest tenth. So you guys are pros at this now. First thing we're going to do is we're going to write down our formula. So volume is equal to 4/3 pi r cubed. We're going to identify that this here is our radius. So we're going to substitute that in. We've got 4/3 pi. And I've got 4 cubed. Now let's not forget that 4 cubed does not mean 4 times 3. It does mean 4 times 4 times 4, and that's going to give us 64. So we get 4/3 pi times 64, and I'm going to just simplify that. So I get 256 pi divided by 3. And I'm going to throw that into my calculator. I get 268.08257. That's going to keep going. And I'm going to round to the nearest tenth. So 268.1. I'm not forgetting my units. I've got centimeters and its volume, so I have to put cubed. Okay, so taking a look at another example, we're going to find the volume of a sphere and we're going to round to the nearest tenth. So again, the first thing we want to do is look at the diagram, and we see that this says 10 feet. Now that represents from end to end, which, do not get tricked, is not representing the radius. We know that the radius then has to be half of that, so that radius means it's going to be 5 feet. So that is one way of tricking you, so just be careful. So again, volume is now equal to 4/3 pi r cubed, writing my formula. So 4/3 pi times 5 cubed. Remember that 5 cubed is 5 times 5 times 5, which is equal to 125. So 4/3 pi times 125. I'm going to simplify that, so I get 500 pi over 3. I'll put that into my calculator. I get 523.5987. That will continue, and that's going to be rounded to the nearest tenth, so 523.6, and my units is feet cubed. So at this point now, you should be just testing this out in your calculator and double checking that you're getting the exact same numbers. And if you're not, then you might need to check for brackets or see the way that you've set it up on your calculator. So here we are at your first 2 try problems for this video. You're going to find the volume of these spheres and you're going to round to the nearest tenth. So pause the video, try these 2 questions out, and then continue. So before we get on to our last example of this video, we just need to do a quick little prior learning, just like we did in the video of finding the volume of a cone. So if I had, for example, x cubed is equal to 8. Well, this is asking me that what number multiplied by itself 3 times over, so x times x times x, is going to give me 8. And that number is going to be 2. So in this case, if we solve that equation above, it's going to be x is equal to 2. Now if I had the equation x cubed is equal to 27, we're asking ourselves the question, x times x times x is equal to 27. So what is x? And in this one, the answer is 3. Now, again, 8 and 27 are kind of special. These two are special numbers. And these special numbers are called perfect cubes. So 8 and 27 are not the only ones. We also have, for example, another example is 64. And 64 because 4 times 4 times 4 makes 64. Now, another example is going to be 125 because we have 5 times 5 times 5 makes 125. So these are all perfect cubes, and they're perfect cubes because these numbers are going to give us whole numbers that are going to be its cubed root, because the cubed root of 64 is going to be 4. The cubed root of 125 is 5. But of course, we're not always going to get these perfect cubes as a number that we're going to try to solve. So for example, if we had x cubed is equal to 2. So we're trying to think what number multiplied by itself 3 times is going to give us 2. Well, that one's really difficult for us to figure out in our heads. So we can use a calculator to evaluate this. And what we're going to do in the calculator is we're actually going to find the cubed root of both sides of this equation. And that cubed root is just going to help us isolate for the variable x. So it's just going to help undo the cubing. So we can put in the cubed root of 2 to solve for x. So when we put that into our calculator, we're going to get that x is equal to 1.25992105. So you should be able to try this into your calculator and see if you can get the same result. So on your Desmos app, you'll see the n and the square root sign, and the n is just what kind of root do you want. In our case, we want the cubed root, so you'll put the number 3. And then underneath the square root sign, you'll put a 2. And then a lot of you who have this calculator here, you're going to have to press the second function button and this button right here, because above it you'll see there's like a little x and then a square root sign, and that will help you find the cubed root of your number. So you'll have to press, I think, probably a 3 first, then second, and then this button, and then you should be able to put in a 2 to get the same result of 1.2599. In this example, we're going to find the radius of the sphere. So again, we take a look at what we're given. So we're given that the volume is 288 pi inches cubed, and this is the radius, and that's what is the unknown. So we're going to start off by writing our formula for the volume of a sphere, which is V is equal to 4 over 3 pi r cubed. And then we're going to substitute the values that we know. We know the volume is 288 pi, and we have 4/3 pi, and our radius cubed is what we do not know. So in front of our r cubed, we do have this 4 over 3 pi. Now remember, we can think of this as just a number, and we want to solve for r. So we're isolating for the variable r. So if 4 over 3 pi is being multiplied to r cubed, we know that we can divide both sides by 4 over 3 pi. Okay, and then when we do that, this is going to cancel here, and then we're going to be left with that 288 pi over 4 over 3 pi is equal to r cubed. Now it's also good to be able to simplify this 288 pi over 4 over 3 pi. So if we do that, I'm just going to take it to the side here. So 288 pi is being divided by 4 pi over 3. And if I'm dividing with a fraction, I'm going to put this over 1. So 288 pi over 1, change it to 3 and 4 over pi. So if we see this, hopefully you're noticing that I can cancel the pi's. There's just one on the top and one on the bottom. And if I look at 288 and I look at 4, they are both definitely divisible by 2 because they're both even. And they actually are, in fact, divisible by 4. 200 is divisible by 4, and so is 88. So 288 divided by 4 is going to give me 72, so this simplifies to 72, and this 4 will simplify to 1. So now I get 72 times 3 on the top, which is going to give me 216, and 1 times 1 on the bottom, which is just going to give me 1, so I'm left with 216. So now I have that we've got 216 is equal to r cubed. Now, 216 happens to be a perfect cube, but if we weren't able to recognize that right away, then in order to isolate for the variable r, we would take the cube root of both sides. So this is going to be the cube root of this side here and the cube root of this side here to solve for r. And then we get that the cubed root of 216 is equal to r, and therefore r is equal to 6, and we need our units, so 6 inches. And it's just going to be inches because we're not looking at the volume, we're just finding the radius. So let's say if you did not realize that 216 was a perfect square, we could still use the calculator to help us figure out what the cube root of 216 is. So on your calculator, you should see a button that looks kind of like that one I just highlighted here. It's got like an n and a square root sign, but this n here means we can make it the cube root of something. You can also change the n value to like the 4th root of something, but we're going to be using the cube root. So we are going to then use this button, and then at the top here you're going to input that you want 3, and then inside here you're going to put 216, and you'll see the answer is 6. So you'll have to just play around with the calculator if you're not using the Desmos calculator, and just check out and make sure on your calculator you know how to find the cube root. So we're going to take a look at your last try it question of this video. You're going to find the radius of this sphere, and you're going to round your answer to the nearest tenth. So keep in mind that you're given the volume, you're looking for the radius, and you want to write down your formula first, and then substitute what you're given.